Hello, my name is Leon and I am one half of the two-people team behind the gardening game GOLEMBERT, and today I want to walk you through our Unity setup. I want to make this video as accessible as I can for people that aren't that familiar with the Unity engine, but I think this will still be a great video to watch even if you are working professional in Unity all day every day, because now you can see how I work in it.
Okay.
I also recommend you to watch this video on a wider screen than the one of your phone, because the whole Unity UI is just super teeny tiny. I will try to zoom in as much as I physically and emotionally can, but if you are still watching this video on your phone after that grand disclaimer...
Are you crazy? Are you out of your mind?
Point 1. What is Unity? Unity is a game engine. There are other game engines out there like Unreal or Godot, but because we learned Unity in university, we use Unity. To explain an engine in my civilization lingo, a game engine is a wide software that combines different specific tall functionalities that do not have to depend on another, but make it more comfortable to make a game and their combination within an engine than from scratch. It sounds weird, but most softwares work that way when you think about it. Excel, for example, is a wide software combining the specific tall functionalities to display and calculate data. That means that you can use Excel to paint pixel art, make a spreadsheet, or even code a simple game in it. The spreadsheet part is the one Excel really excels in, because it uses the two main functionalities best. Game engines are very similar, but a bit more complex. Their two main tall functionalities are the display of objects and the iterative execution of code. Because these two functions are pretty abstract, game engines are not that accessible as Excel for beginners, but the combination of these two main functions lead to a similar multitude of things you can do with a game engine, ranging from simulating physics to deep blue-like interactions. But enough about all that theoretical stuff. Let's just dive in and start with point 2. Short walkthrough of the Unity UI. This is how Unity looks like. Well, at least for me using the 2020 version of it. Its UI consists of different sections you can drag and drop different windows to. In our setup, the most important sections are the hierarchy, the scene view, the game view, and the inspector. The hierarchy view on the left side of the screen is super organized and still confusing. The hierarchy is in essence a list of all scenes, with a list of all objects of a scene under it, with a list of all objects of an object under it, and so on and so on. That sounds and maybe looks very messy, but it's a really great way of displaying the inevitable chaos of any form of creation in an easy to access way. While the hierarchy is just a list of objects, the scene view displays all objects of a scene. But what is a scene, you might ask? A scene is essentially a map of objects. Everything you find in the hierarchy has a position and different components, like a renderer that shows a sprite and therefore makes an object visible in a scene. Besides the scene view, in which you can zoom out and in as much as you want, there is also the game view. It is simply all scene objects the main camera, an object that exists in the scene view / hierarchy, can see. This is also what you see as a player while playing a game. The last section that's important to understand a game's engine's UI is the inspector, here on the right side of the screen. It simply displays all components a game object has attached to it. To check out the viewable values of a component, you can expand or collapse it. So when I work in Unity, I mostly use the hierarchy to find specific objects, move them around and arrange them in a way I want in the scene view, and add / remove / modify their components in the inspector. That's kind of the pipeline. The attached components are mostly Unity's own components, like transform, the position, pivot, scale and rotation of an object, colliders, with which you collide or which you trigger when running against / into them with your character, or sprite renderers, which, as I already said, render sprites. The only components that are written by ourselves are C# scripts. Maybe I'll do another video someday about how our code system works if you want to see that mess as well. But let's not dive into that, but dive into how our scene / hierarchy is structured in point 3, our hierarchy / scene setup. The main thing of our scene setup, which you might even already notice, is that we have two scenes active at once, the main scene and the home scene. We initially did that so we could keep data and scripts like the game manager between different level scenes persistent. Because when we started working on GOLEMBERT, we started out with different level scenes for different areas in the game, as it is in most games. But we realized that the whole scene transition, consistent crop growth and save and load system would just work way easier with a lightweight game like GOLEMBERT if all our level scenes were just part of one level scene. So the 2 scenes active at one system is kind of obsolete now. Still, the main scene includes the game manager, the player character and the canvas. The canvas holds all UI elements, which are a lot, and I'll talk about them later a bit more. The home scene includes all environments/areas of the game. Because they are all in one scene, the player simply teleports from one point to another on transition. Therefore, these areas have to be spatially separated enough so they do not conflict with another. This area here, for example, is GOLEMBERT's island. It has transition points into Helios' house and the watchtower. So if you enter the house, for example, you get teleported to another point in the scene that incorporates the house area. Both areas have colliders and camera colliders around them that are shortly disabled to teleport properly. But beside the house and the tower top area, which are just regular small areas in which you can walk around with GOLEMBERT, we also made areas you would normally see as UI into level areas, like the potion crafting map or the Herbert settlement/map. You enter these areas not via walk-in teleporters, but via right-click or a drop-down selection. Then you are teleported to another position in the scene, just as with the house and the tower, but this time GOLEMBERT's renderer gets disabled. So as you can see here, the player character GOLEMBERT is still active, and I can still move around on the potion map using WSAD, but I can now also drag the camera around with the mouse. The latter is deactivated when I exit the potion crafting panel, so you don't drag GOLEMBERT around the island. Only this way we can have multi-level or mixed media, meaning game object and UI object consisting UI panels, like the potion crafting panel, where you can freely move around, zoom in and out, select and deselect stuff, while a permanent inventory is also displayed. Because we have all our in-game areas in one scene, our home scene hierarchy is kind of organized in multiple sub-scene-like empty object parents for the whole island view, Helios' house, the tower top, the Herbert settlement, as well as the potion crafting map. There is also a lot of temporary disabled or obsolete clutter we keep around, as you can see, but that again is part of the chaotic structure of making stuff, I think. The hierarchy of the main scene, which incorporates the game manager, the player character and the UI canvas, looks way more organized compared to the home scene. But behold, just because all the UI panel children of the canvas object are deactivated doesn't mean that they are all still in use. There are, for example, 2 different crafting panels in here. One that is the actual factual potion crafting map UI, and another that was kind of like a puzzle minigame where you had to click the correct sequences of words a potion recipe needed to craft. The cool thing about the canvas UI is, if you haven't already noticed, that it is always displayed over every other game object and that it is always displayed related to the screen/canvas size. Therefore UI panels can simply be turned on and off if you need them, and you don't have to worry too much about their positioning or any kind of transition between them as you have to with scene objects and scene/area transitions. So that's the basic setup we have in Unity, mostly rudimental and replaceable stuff and a lot of monkey business. So what's really doing the magic here, you might ask? Point 4. The magic. The magic really only comes from these couple of C# scripts we wrote, I guess. They define every possible action, reaction and interaction between things. As I said, I can walk you through that code one day too. But beside the inbuilt engine features in these scripts, there isn't really anything external or additional we use except for Xnode, which is a node editor. We used it to build and display our dialog graphs, but while working with Xnode, I personally realized that a simple list of nodes that refer to another is probably as good to display and may even be faster to build a dialog with, at least for myself. But let's end this video on a high note with a fast Point 5. Short Engine FAQ. Question number 1. Why does working in Unity look like working in a logistics software? Working in Unity, working/coding in Visual Studio excluded, does really look and feel a bit like working in a logistics software. You mostly just drag and drop stuff from A to B, check if all assignments are there, if any value is false or true, or if a value changes accordingly to what you envisioned it to change. I think that mostly comes from the main thing one does in a game engine, placing and managing objects. That is very close to a logistics job description. So if you want to make a game, be good at managing objects, I guess. Question number 2. Why don't you use Unreal or Godot? As I said before, we learned using Unity in university. We also used Pygame to learn coding, and there are people out there using Pygame to make super cool games. But Unity was/is just way easier to use. As far as I know, most people attribute Unreal as a great/better 3D engine than Unity, but I haven't heard that it is any better for 2D games, therefore we haven't really thought about Unreal before. Godot really bubbled up in the Unity scene after that pricing mess Unity introduced at the end of 2023 and later watered down. GOLEMBERT is a game that doesn't really need a lot of engine features to be made, and our future projects will probably stay in the same 2D, homemade, C# heavy fashion. Therefore Godot is really high on our list of future engines, but we do not have the confidence/do not see the necessity to switch from Unity to Godot right now, because we are still on 2020 licensing terms with Unity. Question number 3. Should I also put all my level scenes in one level mega scene? If your game is similar to our game in the way that it is 2D, doesn't have a lot of always active scripts, and just a few different levels/areas, I would recommend you to do so. But if your game has multiple different levels that aren't always accessible, I would recommend you to deactivate these levels/areas completely when they are not needed if you still want to have them all in one scene. If your whole game revolves around different levels, you should probably keep them in separate scenes and load them if needed. Maybe keep your essential game data and player character in a separate scene and try out the 2 scene actives at a time model too. A last question, is the 2 scene active at the same time model something I should use too? A very convenient follow-up question. Having a main scene with all the essential data in it, meaning the manager scripts and the player, is really something everyone should do, I think, as long as one plans to work on a game longer than a couple of months. You really do not need a fancy setup like that if you just want to play around in the engine or make a small game fast. But for a bigger production I would recommend it to keep your data consistent. Okay, that was the last question I'm taking today. Thank you for your input and for watching this video. If you want to check out GOLEMBERT on Steam, you can do that via the link below in the description box. It would really help us if you wishlist the game too, heart emoji. I hope you have a wonderful time wherever you are. See you in the next video. Bye!